Video on how to do inverse normal calculations. Now I'm just going to show you on my CASIO calculator first of all whereabouts that is. So I'm in the stats menu and I just go to distribution norm, and then you can get to your place. Now I've actually got this emulator, it might be a bit easier to show you on here. So if you've got a CASIO calculator, you go to number 2 for statistics, and as I said, F5 for distribution, then norm F1, and then you just go to F3, which does inverse norm calculations. So this is the place that I'm going to be working with. You can see on this calculator here, it's just a picture of my actual physical calculator. And we use it basically when we know the probability of some condition on the normal distribution and we want to find the X values involved. So I'm going to take you through this really quick example down here. So imagine that we've got a mean of 70 on this normally distributed set of data, and we've got a standard deviation of 10. Okay, and we know that 0.3 or 30% of the values of the data are above some value X. Okay, so we've got that set up, right? And our job is actually knowing the probability, so actually knowing this 0.3 here, can we actually find the value of X here, this X value above which the probability of being bigger than X is 0.3. I hope that makes sense there. So what we need to do then is, once we're in this inverse normal area, okay, and I've drawn my picture of the scenario, then all I need to do is make sure that data is invariable. Then I'm going to go to tail. Now my tail part, so the bit that I've shaded, is headed right, isn't it? Okay, if I shaded this part here, it would have been left. But I'm on the right side of this line at X, aren't I? So I need to change that to right. So I'm going to press F2 for right. And then the area underneath that, okay, so press execute. So right, oops, whoa, no, I don't want to do that. Okay, down, area. The area, okay, or the probability of being greater than X is 0.3. So I'm going to put that in. And then my sigma, which is my standard deviation, is 10. And my mu, otherwise known as my mean, is 70. And all I need to do at that point is press execute now. And I've put all the data in to describe what that picture looks like. And I can see that that X value is actually 75.2 to 3 significant figures. Okay, so that's my answer. So I can just get my pen back. And what did I say? X is 75.2. That's what I said, wasn't it? Okay, and we can look at it and think, is that a sensible looking answer? Well, yes, it's greater than 70. It's on that right hand side of the mean. So yeah, looks good to me. Okay, next one. So now I've got a bit more of a wordy question here. So this is more like a standard sort of IB applications question. So the volume of cartons of milk is normally distributed with a mean of 995 millilitres and a standard deviation of 5 millilitres. It is known that 10% of the cartons have a volume less than X, so find the value of X. So again, right, big tip here is always when you're given a description like this, you can't really, I mean, you can, but I like to visualize it as a normal distribution. So what I'm going to do is actually start to draw it out. So I've got, what do they say the mean was? 995. Sigma is 5. And it's known that 10% of the cartons have a volume less than. So over here, right, and only 10%. So remember that 50% of the data is on the left-hand side of the mean. So if I'm only talking about 10% being less than some value X, right, then that's 0.1, isn't it? 10% are less than some value X. Yeah, okay. So that's my picture set up. And now I just need to go back into here. I'm going to go press exit and just put those values in. So this time my tail's going to the left, isn't it? It's less than. So left, and then I'm going to go down and put in the area, which is 0.1, and I'm going to put in 995, which is, oh no, it's not, hang on, no, it's sigma next, isn't it? It's 5, and then it's 995 for that one. Okay, and that is 988. So yeah, it looks right again, doesn't it? Okay, because whereabouts it is, its position. Now let's make sure, is that 3 significant figures? 989 actually, so 3 significant figures because it's 0.5. So 989 mils to 3 significant figures. Okay.